and it'll come out to 9. Doesn't matter, you can go either way, but the linear ratio is either 13 to 7 or 7 to 13.
Mm-hmm.
And I'll tell you why 13 to 7 works a little bit better. Because the next thing you have to do is get the area ratio. What is the area ratio, big to little? How does it compare to the linear ratio?
Isn't it squared?
Yes. Area ratio is the linear ratio squared. Volume ratio is the linear ratio cubed. So what's the area ratio here?
It would be with the 13 on top or the 7?
I like going big to little. Let's go big to little.
Okay, then it would be 169 over 49.
So that is the area ratio. That first one is the linear ratio. And what's the volume ratio?
It is...
You're probably going to need a calculator. I don't know what this is, but it's 13 over 7 cubed. What is that?
It's 2,197 for 13. And then 7, it is 343.
Okay. And that number can be divided by 9. This number here cannot be divided by 3 or 9. So that's probably simplified. But that's the essence. In other words, the essence of these problems is the area ratio is the square of the linear ratio, and the volume ratio is the cube of the linear ratio. And it wouldn't matter whether you're going big to little or little to big, but it will make a difference in some cases as to how hard or easy the math is. So what is the volume that they seek?
I have no clue.
Well, our volume ratio is that, right?
Yeah.
So that, big to little, has to equal the volume they give us, 8788 pi over x. And then just solve for x. In other words, whatever the math comes out to be for that. Do you have a calculator in front of you?
I do, but he wants us to like write it down first, which is very annoying.
Okay, so that's what you want to write.
And then
Is that ratio. In other words, the volume of the big is this ratio relative to the volume of the small. So x is going to come out to some number of pi.
yeah. I don't know, we could always skip that and just do that last.
Okay, you said you do have a calculator?
Yeah.
Go ahead and do it.
I'm just confused on how you're supposed to do it.
Are you just multiply?
Okay.
So we have 121.97x equals 87.88 pi times 343. And I'm going to divide both sides by 2197. So my answer is going to be whatever that number is in your calculator. Take 8788 pi, multiply it by 343, and divide the whole thing by 2197. What do you get?
I don't know if this is correct, but I got 1,372.
Sounds actually correct. What'd you get?
1,372.
Pi or just that?
Pi.
Okay, I was going to say, there should be a pi after that. In other words, that ratio is about 4 to 1, just looking at it. So if I multiply that 343 times 4, I get approximately that. That's why I knew there still had to be a pi around it.
Yeah.
All right, let's look at the next one. These actually all become pretty easy once you figure out the pattern. And this technique that he has here, you always want to do all three. The problem is in number 2, they give you the area ratio, right?
Mm-hmm.
Okay, what is the area ratio big to little?
320 over 125.
What is the linear ratio? How do I get it from the area ratio?
Well, you would do like 320.
It's the square root. Whatever the area ratio is, the linear ratio is the square root of it. So it's the square root of 320 to 125.
I keep on getting a decimal.
Well, that's okay. It's going to convert that to a decimal. But you could write the answer like this, or you could write the answer as, what, 1.8 something, whatever.
It's like, for 328, it's 17.88.
Hold on. If you take 320 and divide it by 125, what do you get?
Oh, divided by, okay. 1 second.
Then take the square root of it.
Oh, it's 2.56.
Don't think so.
Well, 320 divided by 125
is how much? Oh, that's 2.56. Then take the square root of it.
It's 1.6.
Okay, that's what I was looking for. So the linear ratio is 1.6 to 1. You with me?
Mm-hmm.
Now here's why I like big to little as opposed to little to big. If I list the area ratio as little to big, like this, just as valid, but then you end up taking the square root of a number less than 1. So then I would take the square root of 125 over 320, and you certainly don't get 1.6, you get a fractional number, perhaps, I don't know, 7 to 10 or something. But go ahead and do this in your calculator real quick. What's this? First of all, what's 125 divided by 320?
It's like 0.39.
Okay, so you're taking the square root of 0.39. What do you get?
0.625.
Yeah, 0.625. Well, 0.625 is the same ratio as 1.6. In other words, it's just this is big to little, this is little to big. Okay? Now here's the difference. When you're going big to little, you're always taking square roots of positive numbers greater than 1. When you're going little to big, you're taking the square roots of numbers that are less than 1, which is always stranger, because when you take the square root of 0.39, notice your answer is a bigger number. It's 0.625. So it's more confusing to take the square roots of numbers between 0 and 1, and that's what you have to do if you're going little to big. That's why I prefer big to little, because everybody understands that the square root of 4 is a smaller number, correct?
Mm-hmm.
What's the square root of 1/4?
1, 8.
Ah, see? It's 1/2.
Oh.
When you take the square root of a number smaller than 1, it gets bigger. 1/2's bigger than 1/4. So this is more confusing for everybody than this is. In other words, if I'm doing big to little, I'm going to be doing that kind of math. If I'm doing little compared to big, I'm going to be doing that kind of math. And this is always more confusing because most people don't want to come up with a bigger answer. It's just like your first answer was 1/8. The natural tendency is when you take the square root of a number that it should be smaller than the number you're taking the square root of, but it isn't if it's a fraction. And whenever you go little to big, you're going to have that fraction. Okay, so let's see. Let me make sure we get back to where we started from here. Our R sub A was little to big 320 to 125. Our R sub L, you said, was 1.6.
Mm-hmm.
Okay, that's 16 to 10. What's R sub V relative to these two?
For 16, it would be 496.
Well,
4,000.
it's 16 cubed, right?
Yeah, it's 4,000.
So it's 16 cubed divided by 10 cubed. So that's, what is it, 4,000 what?
96.
4,096 divided by 1,000. So that ratio is greater than 4 to 1. Notice something else, that our linear ratio was 16 to 10, wasn't even 2 to 1.
Mm-hmm.
Our area ratio was more than 2 to 1, but not quite 3 to 1. But by the time you get up to the volume ratio, we're at 4 to 1. So these things don't stay the same. In other words, when you have a linear ratio of 2 to 1, the area ratio is 4 to 1, and the volume ratio is 8 to 1. So if we know that's our volume ratio, and we know the volume of the big is that, how do we get the volume of the little? Let's always set up a ratio. In other words, 4096 is to 1,000 as what? Go big to little.
320.
Hold on, don't give me just a number. Give me the expression.
So, would you do the RA?
Do the big first, the volume.
Okay. So 320.
No, 3,072. Remember, we're doing the big when we do volume. So we're using this ratio.
Oh, yeah, okay.
It's 3072 to x.
Yeah.
Being what we're trying to solve for. Okay, so how do you solve that equation?
Um, you cross multiply and then divide.
Exactly, cross multiply. So you got 4,096x equals 3,072,000, and then x equals that number divided by 4096. What does that come out to be? Let's get an answer.
750.
750?
Mm-hmm.
Okay. Does that make sense?
Yeah.
Always apply the ballpark estimation here. Yeah, 750, well, 3,000 is just about 4 to 1 bigger than 750. So that's what it should be. In other words, once we know the ratio is 4,096 to 1,000, that's 4 to 1 essentially, then we know that this volume has to be 4 times this volume. All right. All of these are the same once you understand this basic relationship on how, in other words, I love the way he puts all three of them on every problem. Okay, on this one, he gives you the volume ratio. So we know what R sub V is. What is R sub V?
3,087 over 576.
What's that make R sub L? How would you get it?
Well, you would do 387 divided
Not
by...
divided by. Take the cube root of this. Of whatever that number is, take the cube root of it. And you can either take the cube root of the numerator and divide it by the cube root of the denominator, or you can just put that in and take the cube root of your answer. Either one is the same.
So would I do 3,087 cubed?
Now, here's what you do in your calculator. If you want to do it easily, you take this whole thing to the 1/3 power. That's taking the cube root of it. What do you get?
I don't know if this is correct, but I got
1 point
8.
something.
Yeah, no, that's not correct. I don't know.
Okay. Let me bring up Wolfram Alpha here and let me put it in. Make sure you understand how you find the cube root of this. All right, let's see. I got 3,087 divided by 576. 3087 divided by 576 raised to the 1/3 power. That's what you do when you take the cube root of something, is you raise it to the 1/3 power. Just like when you take the square root of something, you raise it to the 1/2 power. Okay? Well, the exact result is 7/4, which is about where I thought it should be. 7/4. So that's what this ratio is. 7/4. Another reason why I want to go big to little. Because if we go little to big, does Hansack still go little to big?
Yeah.
Wow. When you go little to big, notice that this number down here is like 1/6 instead of 6 to 1, or 1/5 rather. Well, when you start taking the cube root of 1/5, it really confuses people. Whereas if I take the cube root of a number greater than 1, I know it's going to get smaller, not bigger. Well, this ratio got smaller, right? It went from approximately 5 to 1 to 7 to 4. That makes lots of sense to me. That's why you want to go big to little. We can do the rest of the problems little to big if you like, just because I don't want to confuse you and do it different than Hansak's doing it. But let's finish out this problem, big to little. So what's the area ratio? If the linear, in other words, we figured out the linear ratio, now we still need the area ratio.
49 to 16.
Yeah, notice how easy it is to square that, 7/4. Okay, now the rest of the problem says they want to know what the height of the bigger is. So which ratio are we looking at? We're looking at volume, area, or linear when they are talking about the heights.
Is it linear?
Yes. In other words, when you're talking about one dimension, that's linear. And height is only one dimension. Height's going to be measured in inches, not square inches, not volume inches, or cubic inches, but inches. That is a linear measurement. So if they've told me that the height of the smaller is 12, what's the height of the bigger?
What would you do, like 7/4 equals 12?
Well,
Over.
you could just think about it, and it's 7/4 times 12, right?
Oh, yeah.
In other words, the bigger has to be 7/4 of the smaller. So I could say 7/4 times 12, but if you must set up a ratio, then it is the smaller is the 12, right? So the bigger is the numerator, the x, and then x is equal to 7/4 times 12. If you do the algebra on that ratio, you get x equals 7/4 times 12, which is 21. So x is 21. That's the answer for the height of the bigger pyramid.
Okay.
Okay? And all of these questions are really exactly the same. You merely have to find all three ratios. Each one of them starts you off with a ratio. In other words, number 3 gave you the volume ratio. With the volume ratio, you were able to find the linear ratio. Once you had the linear ratio, you could find the area ratio, but the linear ratio was the important one. Well, and number 4, I know we're out of time here, but let me explain how to do number 4 to you. They give you the volume ratio, right? By giving the volume of the big, they gave it to you backwards. Look at that. Am I misreading that?
I don't think so.
Well, would they give you the volume of the big ball? 375 pi?
Yeah, it's backwards.
It's backwards.
Wow, that's a little confusing.
Very.
Okay.
Yeah, especially when he does little to big and I do big to little, and then they give you a problem where it's backwards.
Yeah.
So, but they're giving you the volume ratio. And big to little would be 5184 pi divided by 375 pi, right?
Yeah.
I'm doing big to little. Well, notice that I don't have to, but this is the easiest way to do it. I have to go from the volume ratio to the linear ratio by taking the cube root of the volume ratio. And then I want to square the linear ratio to get the area ratio. Now, once I have the area ratio, I can answer their problem because they're talking about area. They give you the area of the big, that 432 pi. So you have to set up your ratio formula, just like I have on every problem, to figure out what the area of this one is. You want to make
Okay.
sure you can do this problem before I leave you or not?
I understand it.
Okay, cool. And same way with number 5. They give you the volume, big to little. And you can do these little to big. There's nothing that forces you to do them big to little. In other words, if ANSAC really insists you go little to big, then do so. It's the same exact answer. It doesn't change any of the answers. It changes all of these ratios. Instead of numbers greater than 1, you're going to have numbers less than 1. And that's what's a little confusing when you have to take the cube root of numbers less than 1. But that's the only reason. You can go little to big just as easily. Just understand that you have to set up these ratios to get the answer. Once you find your linear ratio or your area ratio, then you have to set up these proportions to figure out what the answer is. All right?
Okay.
All right, Allie. You have a good rest of your weekend, and I'll talk to you next Tuesday, right? Just make sure I've got you down for next Tuesday. I do, at 3:30. In fact, it'll be Tuesday for the next 3 weeks until your semester's over.
Okay. Thank you.
All right. Talk to you next Tuesday. Bye-bye.
Thank you.